299,792 kilometers per second. That is the speed of light. It is the fastest speed anything can travel in this universe. Nothing with mass can reach it. Nothing can exceed it. Every second, light can circle Earth more than 7 times. It can travel from the moon to Earth in just over a second. It can cross the distance between the sun and Earth in about 8 minutes. These numbers are real. They are measured. They are tested again and again in laboratories. Yet behind this famous speed hides a fact that almost no one talks about. From light's own point of view, it never moves. Not slowly, not quickly, not at all. It does not experience distance. It does not experience time. It does not watch the universe pass by, and that is not poetry, that is physics. Modern physics tells us that if you could ride alongside a photon, you would discover that the journey across billions of light years takes 0 time. 0. The moment it is created and the moment it is absorbed happen in the same instant. For us, light from distant galaxies travels for billions of years before reaching our eyes. For the light itself, there is no travel, no ticking clock, no passing seconds. How can something cross the universe without experiencing motion? How can it move through space if from its own reality there is no time to move through? Motion requires time. Motion requires distance. Remove both, and what is left? This is where the rules of everyday life begin to collapse. Cars move because time passes. Planes travel because distance separates 2 points. Even a bullet needs time to leave the gun and hit its target. But light does not follow those rules. At its speed, time slows down completely. At its speed, distances shrink towards 0. These effects are not theory alone. They are confirmed by particle accelerators, atomic clocks on satellites, and precise experiments that measure time differences smaller than a billionth of a second. Astronauts age slightly slower than people on Earth because of these effects. GPS systems must adjust for time dilation, or your location would drift by kilometers each day. This is not abstract science. This shapes your daily life, yet the most extreme version of this effect belongs only to light. When objects move faster and faster, time for them slows down compared to someone standing still. This has been measured with flying atomic clocks. When objects move close to light speed, lengths in the direction of motion shrink. This has been confirmed in high-energy particle experiments. Push this logic all the way to the ultimate limit, and you reach a boundary where time stops and distance collapses. That boundary is the speed of light. Photons, the particles of light, exist exactly at that limit. They do not slow down. They do not speed up. They are born at that speed and remain there until they are absorbed. According to relativity, there is no valid rest frame for light. That means you cannot define a perspective where light is standing still in the usual sense. Yet when physicists explore what the equations imply at that limit, a shocking picture appears. The entire path of a photon across the universe becomes a single timeless connection between 2 events. Birth and absorption become one. Billions of years compress into nothing. The glowing light from a star 10 billion light years away begins its journey long before Earth even existed. It travels across expanding space while galaxies collide and stars are born and die. It passes through cosmic dust and magnetic fields. It bends around massive objects because gravity curves space itself. Finally, after crossing distances so large the human brain struggles to grasp them, it reaches a telescope or a human eye. For us, that is an ancient traveler. For the photon, there was no waiting, no travel story, no aging. The start and finish are the same moment. This is not science fiction. This is the direct consequence of Einstein's theory of special relativity, one of the most tested theories in the history of science. And this raises a deeper tension. If light does not experience time, what does that say about time itself? If distance can shrink depending on speed, is space truly fixed? If the messenger that carries every image of the universe does not experience motion, what does motion really mean? In this video you will learn why time must slow down as speed increases, why distance must contract, and why the speed of light is not just a large number, but a fundamental feature woven into the structure of reality. You will see how experiments with atomic clocks prove time dilation beyond doubt. you will understand why nothing with mass can ever catch up to light, no matter how much energy you use. You will discover the lesser-known implication that photons do not experience the passage of time, which means the sunlight touching your skin right now completed its journey in zero time from its own perspective. You will also explore how this strange fact connects distant parts of the universe in a way that challenges common sense. By the end, the idea of motion will no longer feel simple, time will no longer feel absolute, and light will no longer seem like just brightness that lets you see. It will feel like a boundary between what can age and what cannot. Every image you have ever seen arrived through something that does not experience the act of traveling. Every color, every star, every face is delivered by a messenger that lives outside the normal flow of time. Stay with me until the end, because the final realization changes how you think about reality itself. It reveals why the universe has a built-in speed limit, and why crossing that limit would tear apart the structure of cause and effect. This is not just about light, it is about the rules that hold space and time together. And once you see how those rules bend at the ultimate speed, ordinary motion will never look the same again. Welcome to our channel, where we break down the deepest ideas in physics into clear and powerful truths. If you are curious about the hidden laws of the universe and want to see reality from a new angle, subscribe now and join us on this journey beyond common sense. Motion feels simple. A car moves down a road, a ball rolls across the ground, a bird flies through the sky. We see change in position, and we call it motion. If something is here now and somewhere else a moment later, it moved. That is how the human mind understands the world. Motion means going from point A to point B. It means covering distance. It means time passing during that change. Without distance, there is nowhere to go. Without time, there is no before and after. And without a reference frame, there is no way to measure anything at all. A reference frame is just a point of view. If you sit inside a moving train and toss a coin straight up, it falls back into your hand. From your point of view, it moved up and down. From someone standing outside watching the train rush past, that same coin traveled forward with the train while also moving up and down. Same coin, different motion. Motion depends on who is observing. That is a simple truth we live with every day, even if we do not notice it. Now think about a car on a highway. If the car travels 100 kilometers in 1 hour, we say its speed is 100 kilometers per hour. That number connects distance and time. Remove distance and speed becomes meaningless. Remove time and motion cannot be measured. Even a bullet fired from a gun needs time to leave the barrel and reach its target. It crosses space step by step, even if those steps are extremely small and fast. We trust that time flows the same for everyone. We assume distance stays the same, no matter who measures it. A meter is a meter, a second is a second. That belief feels solid, it feels natural. For most of human history, no one questioned it deeply. Then physics began to dig deeper. When scientists studied objects moving at very high speeds, near the speed of light, cracks appeared in that simple picture. Time was not as fixed as it seemed. Distance was not as solid as it looked. The universe had a built-in speed limit, and that limit changed everything. The speed of light is about 299,792 kilometers per second. That is not just a very large number, it is a boundary written into the structure of reality. Nothing with mass can reach it. No spaceship, no particle with weight, no human technology. The faster an object with mass moves, the more energy it needs. As it approaches light speed, the energy required grows without limit. Reaching that speed would require infinite energy, and infinite energy does not exist in our universe. But something even more shocking happens as objects move faster and faster. Time does not remain steady. According to special relativity, the faster you move relative to someone else, the slower your clock runs compared to theirs. This is not a guess. It has been tested with atomic clocks placed on airplanes and satellites. The clocks that move tick slightly slower than the ones that stay on Earth. The difference is tiny at everyday speeds, but it is real. Push the speed closer to light, and the effect becomes dramatic. time stretches. Seconds for the moving object become longer compared to seconds for someone at rest. At the same time, lengths in the direction of motion shrink. A fast-moving object becomes shorter along the direction it is traveling, as measured by someone standing still. Time slows, length shrinks. These are not illusions, they are physical effects built into space-time itself. Now follow this logic carefully. As speed increases, time dilation increases. As speed increases, length contraction increases. Take this pattern to its extreme limit. At the exact speed of light, what would happen? Time dilation would reach its maximum. Length contraction would reach its maximum. Something extreme happens at that boundary, something that breaks normal thinking. Start with time. If you move faster, your clock runs slower. If you move at 90% of light speed, your clock runs noticeably slower compared to someone at rest. If you move at 99.9% of light speed, the effect becomes enormous. Your seconds stretch dramatically compared to those of a stationary observer. Now push that to 100%, the speed of light. The equations of relativity show that time dilation becomes infinite. That means time, from the point of view of the moving object, stops completely relative to the outside world. No ticking, no before and after, no duration. If no time passes for you, you cannot experience change. You cannot experience motion in the normal sense, because motion requires a sequence of moments. First here, then there. Without time, there is no sequence. Pause there. Let that sink in. At light speed, time does not pass. Not slowly, not differently. It does not pass at all. Now think about what that means for a photon, a particle of light. Photons always travel at light speed in a vacuum. They are not allowed to go slower. They are not allowed to rest. They exist at that limit. From our point of view, light travels through space over time, from its own limit case. No time elapses between emission and absorption. If no time passes, what does it mean to travel? Now turn to distance. Length contraction tells us that as an object moves faster, distances along its direction of motion shrink from its perspective. If you were inside a spaceship moving near light speed toward a distant star, the distance to that star would appear shorter to you than it does to someone at rest on Earth. The faster you go, the shorter that distance becomes. Again, this is not a visual illusion. It is a geometric effect of space-time. Push this effect to the limit of light speed. The equation suggests that the distance in the direction of motion contracts towards zero distance. If there is no distance between where you start and where you end, then there is no space to cross. Combine these two extreme effects. At light speed, time stops. At light speed, distance shrinks to zero. Motion requires time and distance. Remove both, and what remains of motion? For a photon traveling from the sun to Earth, we measure about 8 minutes of travel time. We measure about 150 million kilometers of distance. That is from our reference frame. But in the limit case that describes light itself, there is no passage of time and no separation of space between emission and absorption. The start and the end are connected as one single event in its own limit. This does not mean light has a normal perspective like a human observer. In strict relativity, there is no valid rest frame for light. You cannot ride along with a photon and define a coordinate system where it is standing still. The mathematics breaks down at that exact speed. So when we talk about light's perspective, we are using a conceptual shortcut. It is a way to understand what the equations imply at the boundary, and what they imply is powerful. The journey across billions of light years from a distant galaxy to your eye is experienced as zero time in that limit. The entire path collapses into a single connection. Now feel the scale of that idea. Light leaving a galaxy 10 billion light years away began its journey long before Earth formed. It crossed expanding space while stars were born and died. It moved through regions shaped by gravity, curved by massive objects, stretched by cosmic expansion. For us, that is a story that spans billions of years. For the photon, There is no waiting, no aging, no long road through space. Emission and absorption are linked without duration. That is why the paradox becomes clearer. From our frame, light moves across vast distances. From the limit case tied to its speed, there is no experienced movement at all. Motion as we understand it depends on a flow of time and a stretch of space. Light sits at the edge where those concepts break. It forces us to question whether motion is absolute or relational. It forces us to see that time and space are not fixed backgrounds. They are flexible. They bend and stretch depending on speed. And at the ultimate speed, they collapse in ways that defy everyday thinking. Now bring this back to something simple. The sunlight touching your skin left the sun about 8 minutes ago. Those photons were created in the hot core of the sun through nuclear fusion, then scattered for thousands of years inside the dense solar interior before finally escaping into space. Once free, they traveled the distance between sun and earth in about 8 minutes by our clocks. Plants use that light for photosynthesis. Your eyes use it to see. Your skin feels its warmth. But in the limit description tied to light speed, those 8 minutes do not exist for the photon. The moment it left the sun and the moment it touched your face are not separated by time in that extreme picture. Now stretch this idea across the universe. Light from distant galaxies has been traveling toward us for billions of years. When astronomers look deep into space, they are seeing ancient light. They are seeing galaxies as they were long ago. That light crossed unimaginable distances. It passed through expanding space-time. It carried information across cosmic history. Yet in the boundary case defined by its speed, there is no elapsed time. The connection between distant events is immediate. In that sense, light becomes a bridge that ignores the normal flow of time. This does not make time an illusion. It does not mean distance is fake. For us, time flows. Distances are real. Journeys take duration, but light reveals that these concepts depend on the observer's motion. It shows that the universe is built on a deeper structure where space and time are woven together into space-time. And at the speed of light, that fabric reaches its most extreme behavior. Time stretches to its limit. Space contracts to its limit. Motion dissolves into a boundary condition of reality. As you sit still right now, light from your surroundings is entering your eyes. Photons bounce off walls, objects, and faces carrying information. They move at the same universal speed no matter how fast the source or the observer is moving. That constancy is the foundation of relativity. It is why time must slow down and lengths must shrink. If the speed of light is the same for everyone, then space and time must adjust to make that possible. And those adjustments become infinite at the limit. So the paradox stands firm. Light travels across the universe. It connects stars, galaxies, and planets. It shapes life on Earth. It carries the history of the cosmos. Yet at the very speed that allows it to do this, time does not pass, and distance does not stretch in the usual way. Motion, as defined by distance over time, loses its meaning at that boundary. From our frame, light races. From the limit defined by its nature, there is no race at all. And that tension sits at the heart of modern physics, waiting to be explored even deeper as we continue forward. We measure reality with time and distance. We measure how far something travels. We measure how long it takes to get there. We build our entire understanding of motion on these two pillars. Seconds tick forward. Kilometers stretch outward. Everything we know about movement fits inside that frame. A runner crosses a finish line after a certain time. A rocket reaches orbit after traveling a certain distance. Even the story of your life is told in years lived and places visited. Time and distance feel solid. They feel permanent. They feel untouchable. But light does not live inside those limits the way we do. Light moves at the ultimate speed limit of the universe, and at that limit the rules bend until they almost break. Time slows as speed increases, distance shrinks as speed rises. Push both to the extreme, and something astonishing happens. Time reaches zero. Distance collapses to nothing. The two pillars that define motion disappear at the boundary where light exists. From our point of view, light crosses space. It takes 8 minutes to travel from the sun to Earth. It takes years to travel between stars. It takes billions of years to cross the visible universe. That is our measurement. That is our experience. But at the limit defined by relativity, the photon does not age during its journey. There is no ticking clock attached to it. There is no sense of before and after. In that extreme picture, emission and absorption are connected without duration. The path through space is compressed into a single link in space-time. Motion, as we understand it, requires time to pass and distance to separate two events. Remove those, and motion loses meaning. This forces a quiet but powerful question. Maybe motion is not absolute. Maybe it is not a universal truth that exists on its own. Maybe it depends entirely on the frame from which it is observed. What feels like a long journey in one frame can shrink into nothing in another. What feels like years in one system can become a frozen instant in another. The universe is not built on fixed seconds and rigid meters. It is built on relationships between observers, speeds, and space-time itself. And if time can slow down, stretch, and even stop at a limit, then maybe time is not as fundamental as we once believed. Maybe it is not the deep foundation of reality, but a feature that emerges from something even deeper. Light stands at that edge. It exposes the cracks in our everyday thinking. It reveals that the flow of time is not universal. It reveals that distance is not absolute. It reveals that the fastest thing in existence does not experience the journey the way we do. The sunlight warming your face right now left the sun minutes ago by your clock. The starlight entering your eyes tonight may have traveled for thousands or millions of years. Some of the light captured by powerful telescopes began its journey billions of years before Earth formed. That light carries the history of the cosmos. It tells us how galaxies were born. It tells us how stars evolved. It allows us to look back in time. Yet the messenger that carries all of that information does not experience the waiting. It does not feel the distance. In the extreme limit of relativity, it connects events without living through the space between them. The thing that lets us see the universe may not experience the universe at all. Sit with that idea for a moment. Every image you have ever seen arrived through something that does not move in the way you move. Every sunrise, every face, every distant galaxy reached you through a messenger that lives at the boundary where time and space behave in ways that challenge common sense. Light is not just brightness, it is a window into the structure of reality itself. If this changed the way you think about motion, time, and the universe, then this is only the beginning. There are deeper layers to explore, stranger ideas waiting just beyond the edge of everyday intuition. Subscribe to the channel so you do not miss the next journey into the hidden laws that shape existence. Like this video if it expanded your perspective. Share it with someone who loves big questions about reality. The universe is far more mysterious than it first appears, and together we will keep uncovering its secrets, one idea at a time.